All right. Hi there, Lily. I just wanted to kind of show you where we went wrong in our example. So the one thing that I didn't take into consideration is you have to determine kind of where you are in relationship to the X and Y axis. So our first example that we worked out, in that example, C was the weight was 210 newtons, right? And then you had B rope pulling on that and the A rope pulling here, okay. So then if I want to write in kind of my coordinate system around here, like that, kind of gives me a better idea of where these things are. So when I draw my triangles, again, this was 60 degrees, right? And up here, this was 45 degrees. And so what we're looking for here, component-wise, is we're looking for A sub y and A sub x here. And then we are looking for B sub y and B sub x. This is our first example. Okay. So when we do this, when we combine our components, we end up with, you have to take B sub y. Well, let's first get our components, I guess. Let's first get our components. So B sub y, that angle is opposite 45. So it's B sine 45 because it's opposite. And then B sub x is adjacent to the 45. So B sub x is B cosine 45. Okay. Then when we do our A components, which I'll put here, A sub y is adjacent to the 60. So it is A cosine 60. And A sub x is opposite 60. So A sub x is A sine 60. So we did all that before, and that's not changed. What we didn't do correctly was how we combined the components. We ended up with the right answer, but the sign was wrong. So when we do this, we look at kind of where are these in relationship to the particle. B sub y is above the axis, and A sub y and the 210 are below. So to combine these, we have to take B sub y and then subtract A sub y and 210 to get 0. So B sine 45, and then you subtract A cosine 60 and 210 to get 0. Okay? And because B sub x and A sub y are on opposite sides, here you have to subtract them also to get 0. So B cosine 45 minus A sine 60 equals 0. So that's something we didn't do correctly last time. Okay? So the same process then ensues. You have to then isolate and solve for, because I'm trying to find A, so I'm going to isolate and solve for B here. So B cosine 45 is equal to A sine 60. And I'm going to solve for b, so divide by cosine 45, divide by cosine 45. So b is equal to a sine 60 over cosine 45. Okay, then I'm going to take this and I'm going to plug it in here. So let's do that over on this side. So a sine 60 over cosine 45 times sine of 45 minus a cosine 60 equals 210. So let's figure out this part here first. So I take sine 60 divided by cosine 45 equals, and I'm going to multiply that by sine 45. Okay, so I get 0.866 a. And then I'm going to subtract it by a cosine 60, and the cosine of 60 is 0.5. So 0.866 minus 0.5 is 0.366a equals 210. And when you divide through by 0.366, equals 573.8 newtons. Now we got the right answer before, but we had it set up marginally wrong. And the reason why that's important is because if you don't do it conceptually the right way, then you're going to make mistakes. So that brings us to our next problem, and I'll show you why it's important to do what we just did. Okay. So the problem that we had was where you have a particle here, and now the weight hanging from it was 30 kilograms, so 30 times 9.8, 294 newtons, right? And then we had B here and A here. And for each of these situations, this is 60 degrees. Okay? And again, I'm going to finish drawing my Cartesian coordinate system. So in this one, this is my axis, right? So now, when I divide these into components, x and y, we have b sub y, a sub y, a sub x, and b sub x. And hopefully you can see that I'm going to have to add these two together and subtract this one because they're both above the x-axis. And since these two are opposite each other, you subtract them to get 0. So that's the reason why that direction is really important, because if you don't do that correctly, you end up with something that doesn't work out mathematically. Okay, so again, let's solve for b sub x and a sub x and b sub y and a sub y. So b sub x is going to be adjacent to 60. So we can say b sub x is equal to b cosine 60. And b sub y is opposite 60. So b sub y is equal to b sine 60. The same thing is true on the other side because we're given that same angle. So opposite is a sub y and adjacent is a sub x. So a sub x equals a cosine 60. A sub y equals a sine 60. Okay, and so this is why it's really important to get the picture right. Okay, so then when we add these together, our x components are opposite in direction. So you'd have to say, this is negative, that's positive. So I'm going to go with b cosine 60 minus a cosine 60 equals 0. Initially, we had put that as plus, and you don't want to put that as plus because they're on opposite sides of the y-axis. So that's where our mistake was. And I just wanted to do that first problem for you to illustrate that in actuality, we should have set it up slightly different as well. It still ended up working out with the same magnitude, but it gave us the opposite sign in the end, and that's the correct answer. And then we do our y components here. So a sub y is, well, let's do them together. B sine 60 plus a sine 60. Both of them are above the x-axis. Minus 294 because it's below the x-axis equals 0. Okay. So then again, isolate and solve for b here. Again, if we're going to solve for a, isolate and solve for b. B cosine 60 equals a cosine 60. And again, what you notice is if I divide through by cosine 60 on both sides, they're going to cancel. So basically b and a are the same. B equals a. So when I plug that back in here, it ends up with a sine 60 plus a sine 60 equals 294. Sine 60 is 0.866. So a 0.866 plus a 0.866, which is 1.73a equals 294. Divide through by 1.73. A is equal to 169.9 newtons. And we actually know that B is going to be the same because remember A is equal to B. Okay. So that's very, very important that we have the signs correctly, that we do the math relationships correctly so that we end up with the correct answer, because the other way around, we ended up with something that said like 0 equals 294. And that was a red flag that said, oh, we screwed up somewhere. Okay. Hopefully that makes sense to you. I think one thing that you need to work on is just remembering which one is sine and cosine, that one we talked about before. But then, draw the picture and just use the x and y axis to orient yourself to know if you're adding or subtracting. So I hope that helps, Lillian. If you have any other questions, let me know.